So yeah, as Philip said, I'm Chelsea Harbach. I'm on his team, the commercial ag team with Illinois Extension, and I'm branching out a little bit today. While I am a plant pathologist by training, for 5 or so years, I've been pretty deep into the world of nematology, specifically soybean cyst nematodes. But I really thought it was important to take a moment to talk about scouting, mitigating risk for fungicide resistance development. And you might be wondering, why are we talking about this right now? We don't have, we're just, thinking about, it might be getting soon, or it might be time to start planting soon. We don't have anything out in the field unless you've got wheat. Well, what really sparked this for me was something that I was seeing around online the last couple years, sometimes on Twitter, just kind of in the ag universe online, suggesting that if X was a problem in 2020, it's going to be a problem in 2021. And that is, that's not necessarily the case. In some instances, there are some diseases that, will be in your fields, but it's more complicated than just, being a problem one year. It's definitely going to be a problem the next year. So that's why I really wanted to reintroduce one of the most fundamental concepts in plant pathology, and that is the plant disease triangle. Now, hopefully I don't have any like eyes rolling in the back of the head. I don't want people falling asleep. This isn't a college course, although like the first time I learned about the plant disease triangle was in my intro to plant pathology course at Illinois. It is really just a fundamental concept when it comes to plant diseases. So maybe this is new to you, that's great. I just want you to remember this really easy concept and then think about ways that we can apply it to disease management. So what is a plant disease triangle? Being a triangle, naturally it has 3 components, and the idea is that you need to have these 3 components in order for disease to happen. So those 3 components that we have are the pathogen. These are all cartoony drawings of a nematode, a bacteria, a fungus, and a virus, the like 4 pathogens that we might think most about in our field crops. We've got, of course, the plant, which is the host, and then the environment in which those exist. Now, it is a little more complex than that. We can't have just any pathogen or just any host in any environment to see disease. We need to have a virulent pathogen, so a pathogen that has the ability to cause disease, a host that is susceptible, and then those 2 things need to exist in an environment that is conducive. So, these are the 3 things that we need, or that when come together perfectly in the right time, will lead us to see disease development. And we can also complicate that just a little bit more by adding a 4th leg and turning our disease triangle into a disease pyramid by adding this 4th element of time. Time obviously is, we can kind of, it's something we might forget to think of. I'm not going to address it much going forward, but it is an important component when we think about disease development, because we can't just have a virulent pathogen, a susceptible host, and a conducive environment occur in any one moment. Those things are going to have to exist in that moment, but it's going to have to be an extended moment for the pathogen to be able to grow and develop disease on that susceptible host. But for simplicity's sake, I'm just going to continue with the disease triangle, but I ask that you not forget about that time element, because that's something that can be helpful when you think about, when different diseases might be a problem in different times, depending on, the forecast maybe. An example might be, if you've got soybeans out in the field, canopies closed, they're flowering, and you see in the forecast an extended period of like cool, wet weather, you're going to be worried about the development of white mold. That's a nice little easy example of how time factors in there. So why are we talking about the disease triangle? As I mentioned, it's really fundamental concept in plant pathology, but where it can come in handy to not forget about the plant disease triangle is when you think about making management steps and taking any steps you might take to mitigate fungicide resistance development. It's gonna be helpful to remember that the disease triangle exists. But it also might be a little helpful if you know a little bit about the biology of the different pathogens or the disease cycle. Now, I'm in no way asking or expecting, anyone who's not a plant disease nerd like me to just know off the top of their head bits of biology or the disease cycle of these different pathogens. So while I ask you to remember the disease triangle for, the simplicity, just those three components, it can be helpful to know about the disease cycle and pathogen biology. So if you ever have any questions about that stuff, you don't have to know it, but we're here. We're happy to answer questions. So if you have questions about any of this stuff, reach out to your state specialists, extension educators, or folks at your seed companies or seed dealers might be able to answer questions as well. Now I'm gonna go over the disease triangle and how it applies to two pathogens that we saw in 2020. The first one I'm going to talk about here is tar spot on corn. This is a fungal pathogen caused by Phyllocaramatus. This fungus is an obligate parasite, which means that it needs a living host to grow and reproduce. And this is a pathogen that is still relatively new. I'm sure you're all aware. It arrived here in 2015, and we did see it in epidemic proportions in 2018. And this is the current distribution of tar spot. These are the grayed in areas are all the places that we have seen tar spot to date. So this is from the end of 2020. Obviously, we see it covering most of Illinois, most of Indiana, most of Iowa, making its way up into Wisconsin and Minnesota, Michigan, even into Canada, and then a couple other blips here on the map. So it is still relatively new, but it's here, and it's likely here to stay, given the biology of this disease. So this pathogen is able to overwinter on corn debris, and that's what gives it its that's kind of what makes us think that it's here to stay, and it also can infect some alternative grass hosts. So yeah, it's here, and so this is a disease that's pretty well become endemic to our upper Midwest corn growing region, and is something that we need to be mindful of and pay attention to. Southern rust is the other disease I'm gonna chat about briefly here, quick, addressing the pathogen that causes southern rust. So southern rust is also an obligate parasite, meaning it needs that living host to grow and reproduce. This is a fungus that arrives in cornfields from the south. It relies on those southerly winds to disperse the Uridenia spores northward to infect our corn crops up here. And so there are two rusts on corn. The southern rust only forms pustules on the upper leaf surface. And we're more concerned about southern rust usually than we are about common rust, because this rust, southern rust, is generally more aggressive and yield limiting than common rust. And being that we rely on those spores to be dispersed northwards, this is a fungus that doesn't overwinter in the Midwest. And that largely has to do, it's different from tar spot in that in these pustules you have the Uridinea spores, which can reinfect the corn leaves, but as the corn leaf starts to senesce, those Uridinea spores start turning into Tilia spores, and the Tilia spores they're not infective spores. So while the fungus, you still might be able to find the fungus in the leaves, it's not going to be in an infective state. In tar spot, you have those black spots, those stromata, where you have perithecia, and within those perithecia, we have the ascospores. So those are there and ready to be extruded and infect corn from corn debris in the field. So I'm going to break down here the different components of the disease triangle, kind of compare and contrast these two diseases. Our virulent pathogen are these two, we have these two obligate parasitic fungi. And then when we think about our susceptible hosts, usually we're going to use resistant cultivars to manage diseases, but with tar spot being a newer disease, we don't have resistance available yet in our hybrids. So these data are from 2018. That was the year that we had tar spot at an epidemic proportion. Nathan Kluchevsky observed 98 hybrids of corn for response to tar spot, and they observed the ear leaf at R5 and assessed the percent cover of tar spot on those leaves. And you can see we range here from 25% cover to about 45% cover. So really what we're seeing here is no resistance. These hybrids really just vary in susceptibility. While that's likely to change, for right now we don't really have, we can't say that we have any host resistance. So for the most part, we have susceptible hosts out there for tar spot. And there's a limited availability of hybrids with resistance to southern rust. And since southern rust is usually not an issue in the upper Midwest, those hybrids are generally not going to be suitable for growth up here. And then the conducive environment for tar spot, we're looking at high relative humidity. So this is that doesn't show up until the canopy closes, and you'll see more disease development when you have periods of prolonged leaf wetness. And I didn't put it on here, but tar spot does tend to flourish in more like moderately cool temperatures, so maybe like 75 to 85 degrees versus the really hot temperatures where southern rust thrives in high temperatures, and also likes high humidity. There we go. Okay. So I thought it would be important to show you how disease cycles can help remind us of when and where a disease might be problematic. So for southern rust, as I mentioned, this fungus generally does not overwinter in the United States. It is those Uridinea spores are blown up from tropical regions. So that's can just be a little helpful if you had southern rust this past year, and you're worried about it, in the following year, it can be helpful just to remember that, this pathogen does not overwinter in the United States. Now for tar spot, this is kind of the putative disease cycle, kind of assumed to be the disease cycle of tar spot. When we're looking at the disease cycle and we see that the fungus overwinters on residue, that's just a helpful thing to remember. And that's where I think you find a lot of, or I can find a lot of value in considering disease cycles, and maybe you will too, is just to have this, to see this perspective of where the fungus overwinters, because that can help you with management decisions. And as I mentioned, I'm not asking anyone to like have these memorized, or I don't know, maybe you don't even care, but if you're ever interested about, the biology or disease cycle of any disease, you can always Google it yourself, just Google the disease and the disease name and disease cycle, and you'll usually find nice images like this, or reach out to your state specialist or an extension educator, and they'll help you out too. So how and when, why am I talking about this, and how are we going to apply it to scouting for fungicide resistance management, and why does it really matter for these different pathogens? I'm going to start here with risk factors for fungicide resistance development. And the reason I kind of gave two different pathogen examples is that, it can really vary by pathogen, and I'll address that a little bit more in a moment. Of course, the number of sprays that you use is going to affect resistance development, and that can be tied directly into the types of fungicides that you're applying. So before I dive into those anymore, I want to do a brief overview of how fungicide resistance develops. I'm sure you're all aware, but I think it's worth reminding you occasionally. I'm going to use this graphic here from Crop Life International. It's a nice little graphic. So we have, we have a fungus population in the field. The population isn't going to be completely the same genetically. You're going to have some inherent diversity, genetic diversity of, the fungus in the field, including likely some individuals that have some resistance to fungicides that you're applying. So when you apply a fungicide, you are removing some of those susceptible individuals, resulting in, go back, sorry. Which shifts the dynamics of the population of the fungus in that field. You now have a higher ratio of individuals that are resistant to that chemical, that mode of action. So then over time, as that fungus continues to grow and reproduce, you'll end up just with that higher ratio of individuals that have resistance, and that's what we're trying to avoid, and I'll address that in a moment here. But as I mentioned, risk factors, are going to vary by pathogen. My example that I'm using for that is, so there's known resistance to frog eye leaf spot. The pathogen that causes frog eye leaf spot on soybean is Cercospora. Now, though that pathogen has that single gene mutation and is resistant to strobilurins, we have a fungus in the same genus, the fungus that causes gray leaf spot, is also a Cercospora fungus. When that fungus develops a single gene mutation that confers resistance to strobilurins, that is actually a lethal mutation for that fungus. So yeah, risk factors are truly going to vary by pathogen and very specifically by species. It's not just a genus level thing. And of course, the number of sprays, again, you don't want to do a single application of a single mode of action because you're introducing that high selection pressure event to the population and selecting for individuals that are resistant to that single mode of action. And that feeds directly into the types of fungicides that you're using. It's highly recommended that you use mixes, use multiple modes of action, or at least rotate the modes of action that you're using. So this here is it's not a table, I guess it's a graphic of all of the different fungicides that are out there. And this, of course, is from FRAC, which is a Fungicide Resistance Action Council, or Action Committee. So there's obviously a lot of fungicides, but when it comes to applying foliar fungicides for field crops, we have three modes of action that we're looking at. We have SDHIs, strobilurins or QOIs, triazoles, or DMIs. And this is the one spot here quick I want to point out. The SDHIs and strobilurins are both kinds of molecules that disrupt respiration in the fungal cells, although they have different targets that disrupt respiration. So there has yet to be any documented instances of cross resistance. So even though they affect a very, or essentially the same system in the cells, if you have resistance to strobilurins, it doesn't mean that you will also have resistance to SDHIs. But regardless, still, rotating those modes of action are going to be imperative to mitigating fungicide resistance development. And so, yeah, each of these types of fungicides actually come with their own inherent level of risk of developing fungicide resistance. And those are for our triazoles, that's kind of a medium risk. For SDHIs, that's a medium to high risk, but that's a single mutation. And then our QOIs, our strobilurins, are also a single mutation, and that's a high risk of developing resistance. And that again is sometimes the mutation is lethal. That's where I mentioned the mutation in our gray leaf spot pathogen. And so, yeah, it's the risk of developing fungicide resistance is really, really specific to the species itself and can vary depending on the mode of action you use. And that's why, again, using mixes or rotating modes of action is going to be really important. As far as efficacy of our fungicides on the market, I'm not sure if you're aware of this resource, but I wanted to kind of bring your attention to it as well. The Crop Protection Network puts together these fungicide efficacy tables, and the Crop Protection Network is that's a group of specialists from universities across the United States that kind of compile information from their states to come up with really nice resources for crop producers in the United States. So they actually just released the fungicide efficacy table for soybean diseases for 2021, just came out a couple days ago. So this is up to date. And And again, those can be found on cropprotectionnetwork.org. And this is the corn one from 2020, and I imagine that'll have an updated version that will be out in the near future as well. But this is an example of what you're looking at when you look at the fungicide efficacy tables. You've got the class in the leftmost column, the active ingredient and the trade name. And the rate, and then across the top, we have the different diseases that were assessed, as well as the harvest restriction. And I know it's really hard for you to read, but I'm going to highlight here quick southern rust and tar spot, the two diseases that I've discussed today. And these the letters here are abbreviations for these different ratings that they give in the fungicide efficacy control table. And I know it might be difficult for you to see, so you'll have to take my word on it. But so far, it looks like, you know, most of the fungicides that are labeled for controlling southern rust and tar spot are good to very good. So we have pretty good fungicides out there for managing these diseases, and it's again going to be really important to be cognizant of the fungicides that we're using, and making sure that we can avoid resistance development from these diseases. And that, so I know Nathan, if you attended any sessions earlier that Philip posted, I know Nathan already shared these data, so I'm gonna just kind of breeze over them. But these are results from uniform fungicide trials for tar spot conducted through the Midwest. And you can see that there are some fungicides that consistently work to control tar spot better than others. So I think really, you know, consulting data like these, which again are you can find on the Crop Protection Network webpage, as well as that fungicide efficacy table, can really help you when you're making decisions for fungicide applications to manage different diseases. And these are the yields, again, which correlated to the amount of disease that was seen, with Monmouth being the only location that had any separation in the yields there. And then I wanted to show you quick, these are results from observing how foliar fungicides controlled southern rust and in Belleville in 2020. So these are from Southern Illinois. And you can see there's some differences in the amount of disease that developed from these different fungicides. Some were better than others, and the yields showed that as well. So, you know, if you've got disease problems that you're seeing in the field and need help with decision making between those fungicide efficacy tables and you know, looking for data like that, I think there's a lot of good resources out there. And if you ever have any questions, again, make sure you reach out to your specialists or extension educators. Now time to talk about scouting. So I think, I mean, I know we all probably know, but I just really think that scouting is going to be a really important way to mitigate fungicide resistance development. And that's going to start with ideally scouting both before and after application. Although in some instances, depending on the disease, scouting before may be too late. So that's why it's really important to be scouting regularly. You don't want to start scouting too late and already have, you know, a lot of disease out there, because if you've already got a lot of disease out there and you move forward with a fungicide application, it's possible that you are selecting for more individuals in that population, or it'll still be the same proportion, but there will just be overall more individuals that are, you know, resistant to whatever mode of action you're using. But if possible, you know, scouting before, I think one of the best things about scouting before is that you're able to make that comparison to the amount of disease that you're seeing after the application. And of course, you want to scout about 2 weeks after application to see how effective your fungicide is. And it's just a really important step to take. There's also another tool, I'm not sure if you are aware of. Of course, you know, you probably don't have to monitor these things because extension educators and specialists and seed dealers are monitoring these things and will put information out about them. But there's these ed maps that we use annually to monitor disease progression. That map I showed of the distribution of tar spot is actually one, like an archived map from Ed Maps. But this is one, you know, we monitor all sorts of diseases, but southern rust is one that we definitely keep an eye on since it does move from the south up. So if you were to keep an eye on this, you know, you can see where southern rust is as it moves up during the growing season. And then for tar spot, you know, we're not posting anymore when tar spot is occurring, because you know, I mentioned it's endemic, it's bound to occur. We're mostly using Ed Maps now to indicate new counties that have a positive identification of tar spot, to just kind of track the distribution of tar spot, so our growers know for the future. Oops, did I click too many times? Okay. So it's my hope that you can take and harness what I think is a pretty powerful little concept to help with disease management in the future, because the basics of fungicide resistance management really starts with the accurate disease identification. And, you know, disease is going to be impacted by the disease triangle. I can't emphasize how important it is to make sure that you have an accurate disease identification, and I'll touch on this more in a moment. But if you know, if you're out there scouting and misdiagnose a disease and make management decisions based on a misdiagnosis, you know, that can cost dollars. You know, it costs people time. It's crucial to make sure that you have accurate diagnoses. So if your field agronomist or you are struggling or confused, or I mean, truly it can be pretty confusing sometimes when you're looking at diseases in the field. So never hesitate to send any samples to the plant clinic at Illinois, or if you're in Wisconsin, to the Wisconsin plant clinic. I know at Illinois, they prioritize commercial samples, so they can turn around and give you an identification as quickly as possible to help with your management decisions. And yeah, so I can't stress, I'm stressing a lot about scouting and also disease identification, but these are two really important things when it comes to fungicide management and fungicide resistance management. There are other factors, obviously, that can contribute to fungicide failures. So if you're scouting your field, you know, a couple weeks after your fungicide application, and you're seeing more disease than you think you should be seeing, obviously, one of the things that could be contributing to that fungicide failure, aside from you know, the potential of resistant fungicide resistant pathogen population out there, is an incorrect diagnosis. believe it or not, I've heard of Physoderma brown spot being mistaken for rust in the field. And if you see Physoderma brown spot on leaves and misdiagnose it as rust or southern rust and make a fungicide application to try and control that, that application isn't going to do anything, because Physoderma brown spot infects in the whorl. And so those bands of discoloration are there, and they're not going to get worse. They're not going to get better, but they're not going to be affected at all by a fungicide application. So it's just super critical to make sure that you are getting your diagnosis correct. Of course, there's a possibility of the fungicide being mixed improperly. Maybe the sprayer wasn't calibrated correctly, and poor timing. Nathan, I watched his presentation earlier today, and he had a really nice, I think, explanation for timing of application for tar spot specifically. So I highly recommend watching his presentation and taking in that information, but also consider that the right timing for tar spot management might not be the same for southern rust management. And that's again where scouting is going to come in. You got to be out there scouting your fields and knowing what's in there. So my final thoughts today, again, scouting is essential. Scouting, goes along with a proper disease diagnosis. You want to make sure that you're 100% confident that you know what disease is out there, and that it is actually the disease that you're trying to manage. And obviously, you need to use good integrated pest management practices. That's always going to start with host resistance. And obviously, there's not host resistance available to every disease out there, but that is going to be the best place to start for IPM. Crop rotation is also obviously really good IPM practice, and be mindful of the modes of action that you're putting out there. And again, I'm asking you one more time to remember the disease triangle. It's a really simple tool, or simple concept that really can help you be critical when you're thinking about when and how a disease might start developing in your field. And don't hesitate to ask questions about pathogen biology or disease cycles. And then obviously, make sure you're consulting those fungicide efficacy tables. So there's a lot of really good information in there that can be really useful for making your fungicide application decisions. And that's it for me. I thank you, those of you that are here, and anybody who watches this later, I guess, for your attention. And I am welcome and open to any questions.